Hello, everyone. Thank you for joining. We're going to wait a few seconds to wait for other folks to trickle in, and then we'll start the webinar. All right, I see people are still joining, so we're going to wait a little bit more. All right, it's 11:02, so I'm going to start us off. Next slide. Hello and welcome everybody to the 2021-2022 Better Buildings webinar series. This series is dedicated to bringing you the latest actionable insights from leading industry experts, and it's a chance to explore topics, technologies, and trends that affect your organizations, as well as efforts to accelerate energy efficiency adoption. Today's webinar is titled Planning for the Future, New and Improved Pandemic Protocols. Before we dive in, I'm going to go over a few housekeeping items. Please note that today's webinar will be recorded and archived on the Better Building Solutions Center, and we will follow up when today's recording and slides are made available. Next, attendees are in listen-only mode, meaning that your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the chat located to the bottom of your Zoom panel to our support staff. Next slide. My name is Mariana Ejea Casalduc. I am a fellow with the Building Technologies Office. I work primarily on the Better Buildings Initiative, and I am the Healthcare and Hospitality Sector Lead. Next slide. Wonderful. So today's webinar is special as it's a continuation of our building operations during COVID-19 webinar series, which went on a hiatus this July. The goal of today's webinar is to reflect on lessons learned from the pandemic, look towards the future, and identify best practices organizations can incorporate into their existing pandemic protocols to improve resiliency, improve preparedness, and make plans to enact responsive building operations in anticipation of a future event. You can find all other installments of the Building Operations During COVID-19 webinar series on the Better Buildings COVID-19 Resource Center, which also houses resources from ASHRAE, EPA, DOE, and more. And before I introduce our speaker, I'd like to introduce Marcus Bianchi. Next slide. Marcus Bianchi is a senior research engineer at the National Renewable Energy Laboratory, and Marcus is going to introduce the Space Conditioning Technology Research Team, which is available to all of our Better Buildings partners. Marcus.
Yes, good morning. The Better Buildings Space Conditioning Technology Research Team, in that role, we at NREL and other national labs work on creating materials, guidelines, and other resources that can improve the space conditioning for commercial buildings. We got involved very early on in the epidemic task force, and it's really a pleasure to be here today when Leung will actually talk about the some of the findings that he had on the commercial teams and the pandemic. Next slide, please. We at the space conditioning team, we maintain and collect information about space conditioning as a whole in the HVAC resource map. So this is the link to it. In that, you can actually find a series of resources that we keep updating to make sure that the information reaches to the partners and the public in general. So if you have a chance, please visit. Next slide, please. Thank you.
Wonderful. Thanks, Marcus. Now, today we're going to be using an interactive platform called Slido for Q&A, polling, and feedback. So please go to slido.com on your mobile device or by opening a new window in your internet browser. Today's event code is #DOE. And if you would like to ask our panelists questions, please submit them at any time throughout the presentation, and we will be answering your questions near the end of the session. You can select a thumbs up icon through Slido for questions that you like, which will result in the most popular questions moving up to the top of the queue. Next. Wonderful. So let's learn a little bit more about you. Which sector are you from? Wonderful. I see a strong showing from commercial real estate. Oh, maybe not. Multifamily housing and industrial manufacturing. A lot of higher education, K through 12s, and state and local governments. Excellent. Great to see healthcare and hospitality. A lot of contractors and service providers. That's wonderful. All right, let's scroll back to the top. Great, let's go to our next poll. All right, this question was developed by Luke, and he wants to know, will future health issues be more or less impactful than the current pandemic? All right. I'll give it a few moments. Wonderful. It looks like the majority of you anticipate future events to be more impactful than the current COVID-19 pandemic. That's very interesting. And that's wonderful, because today we're going to be talking about getting ready for the future. So next slide. Wonderful. So today's presenter is Luke Leung. Luke is the Director of Sustainability Engineering Studio for Skidmore, Owings, and Merrill, as well as a distinguished professional with leadership and fellowship positions with LEED, ASHRAE, and NREL, among many others. His work includes the Burj Khalifa, the current world's tallest building, and other 4 of the top 20 tallest buildings in the world. As a reminder, please send in questions for our panelist Luke through Slido by going to slido.com and typing the event code #DOE. And we'll try to get to as many questions that we can near the end of the session. Luke, the floor is yours.
Thank you, Mariana. I think you can see the screen, so if you cannot, just let me know.
We can see it.
Yep. So I think it's really interesting that during the survey just now, a lot of you think that maybe the future could be a little worse than the next pandemic. But hopefully, what we learn from this pandemic can help us to minimize the impact. First of all, a shout out to Professor Bill Barnsley from Penn State. He's the chair of ASHRAE Epidemic Task Force. He helped me to put some of this. Actually, I shamelessly borrow some of his slides. So if you see later the good slides, they are from Bill. And the slides that are maybe not so good, that's from me. So what is the future hold when we look into the future? Pandemic hit us hard. The year was 2019. United Nations told the world There will be 10 things that can derail us from our economy. Global influenza pandemic is only number 3. What is number 2? Non-communicable diseases, chronic diseases, oftentimes has something to do with the environment we are in, partially could be the air we breathe. And number 1, climate change. So looking into the future, there's a holistic elements in the air that can give us some trouble. But you know, there are good news in there. If you look at a lot of the elements in the air, that holistic can impact us. Of course, we're concerned about PM 2.5, responsible for millions of deaths. And also, it's an equitable issue. And it can penetrate deep into our lung. There are tobacco smoke, natural PM 2.5, bacteria, viruses, combustion like the wildfire. But the good news there is if you have a MERV 13 filter, you can take care of many of these issues, even to the submicron level below 1 micron. So there are some holistic strategies that are not particularly costly that can get us good way down there to take care of a lot of these issues. Well, of course, gas molecule is a little different. If you have older issue and stuff like that, you're gonna need carbon filter. So how about the people? Now, today we have about 7.8 billion people, but the percentage above 60 years old, now 8% is actually 1950. So what happened since 1950 till today? People grow, the life expectancy grow, older people live longer, and more people about 60 years old. In fact, 13% roughly of people today are above 60 years old. What about looking into the future? Guess what happened in 2070? Number 1, the people increased to 9.4 billion. Number 2, the amount of people above 60 years old will increase to 28%. And I'm quickly approaching to that 60 years old mark. So it is an issue because if you look at the amount of cost or energy we're going to spend to make people healthy, the mushroom really start at around 60 years old. As we can see in this pandemic, the senior citizen in nursing home hit a lot harder than the other people. So this increasing healthcare costs and energy we have to keep our senior healthy is going to get worse in the future. Not only the population increase, the percentage of the people above 60 also increase. That's issue number 1. But what about a more equitable future? What do we see in pandemic is it doesn't hit the same across all color. If you are Hispanic, Black, or Native Indian, chances are you have 3 to 4 times more likely to be hospitalized, and your death rate is 2 to 3 times higher than Caucasian. But your cases is actually not that significantly higher. So what's going on there? Partially, you're saying maybe there are also other issues that are underlying their health. For example, in this recent study, it indicates 40% of Americans today are still living in area with problematic air, and it's an equity issue because people of color is 3 times more likely to live in those bad air area. Not only that, if you look at the vitamin D deficiency across America, if you're African American or Hispanic American, you are more likely to be vitamin D deficient because you are more likely indoor service industry all the time. So that's why you didn't get a chance to get outdoor to get a dose of vitamin D. It's not just color of the skin, but it's also, like we mentioned earlier, it's also age. in this study here is actually from Michigan earlier on this year. It told us if you are K to 12 school, a lot of outbreaks happen there. Or if you are in senior assisted living, a lot of problems there. But guys, if we can provide even a simple MERV-13 filter in all these facilities, it will get us a portion of the journey down the road already. So there are things we learn from this pandemic that can be applied, not to create a better world, and maybe even a more equitable world moving on. So some of the measures we learned, one of the things you probably remember is inside out. Try to bring some of the activity outside. There's papers, different paper issuing the chance of, kind of the rule of 1,000. The rule of 1,000 is saying if you are outdoor, you have 1,000 times less likely to breathe in anything compared to indoor. So outdoor activities will be good during future COVID or future infectious diseases. But the outdoor space need to study so that they will be flushed through them, because concentration of PM2.5 is not so good during pandemic. We are looking, my day job, I actually have a day job. My day job is a design professional. We are seeing a lot more interest in designing space like that. Have climate space that can open up to outside, maybe with fireplace or fan or some sort of shading device to expand the time of people that can spend outdoor. Because during pandemic, infectious disease time, it's probably a better location outdoor. Now, except if you have high PM10, PM2.5, ozone, and all that stuff in the air, you have to be careful. So some sort of measuring devices, both indoor and outdoor, to tell you which one is better to go is probably helpful. And also space like this. Basically, this is a extruded office building, but with just a south-facing porch, so people can get a dose of sunlight in the noontime to get that vitamin D in there, and also allow them to meet outdoor if they want. This is actually 330 North Green, an office building in Chicago. And also, we see there are interest from Toronto to Australia to different parts of the world to bring more outside in. Now, as you can see later, clean air doesn't have to come from outside, but oftentimes outside air can give you a way to save energy in natural ventilation and provide some clean air, as long as the PM2.5 and ozone, etc. contaminants is not high. Do you know that China just recently updated their building code? Part of the building code, there's a requirement that buildings should look into natural ventilation to save energy, that whole adaptive comfort issue, and also as a way to potentially get it healthier. So something to think about. And also, if you have 3 air changes, you can eliminate 95% of the contaminants indoor. But remember, you do not need 100% outside air to have clean air, which get us right into some of the recommendation we'll be looking at. This recommendation is the core recommendation of the ASHRAE ETF that we will touch on. Now, in the future, if similar epidemic like COVID-19 hit us, we are at least more prepared for the future. But not every epidemic is the same. So we have to look carefully to see how the future epidemic or pandemic may be different than the one we are experiencing right now. So this core recommendation was updated on January 6th. It's quite different than the past. It talks about things that, for example, there's a flexible approach that allow, combining different strategies and care about costs to minimize the energy consumption. For example, the first one, so for a while when the epidemic task force first come out, we thought about increasing the amount of outside air. And then later on, we find out we can actually provide a co-require minimum outdoor air ventilation as a base strategy to save energy. But that has to be, now, one of the reasons why we want to do that is, as you can see on the screen, the x-axis is the dollar to mitigate a unit of contaminants, and the y is risk. So as you can see, MERV 13 filter, it already kind of turned the corner on risk, but the cost to eliminate per unit of contaminant is significantly lower than 100% outside air. So this is a paper done early on in the I think it's 2010 to 2015. But we also did, like, this is actual study in different buildings. So this team looked at 7 different buildings. Now, the first thing is you cannot do 100% outside air in many of the buildings. They were not designed to do that. They don't have the coil capacity to do that. So in this team, look at 7 buildings, only 1 building that can truly do close to 100% outside air. But when you do that to this building, it will cost roughly about 30% more energy and $0.3 to $0.4 per square foot. This building is in New York State. So in the energy standpoint, if you can minimize the outside air, of course, you're going to save quite a bit of energy and money. But you have to supplement it with the recirculation air. It got to be MERV 13 or equivalent. Okay. So this is from ASHRAE Epidemic Task Force website on COVID-19. If it's MERV 13, 1 pass, the droplet nuclei filter efficiency is 89%. So that's actually pretty good, because when you go 2 pass, the first time you got 89%, the second time you got the rest, maybe roughly 10 to 11%, and 89% of that. So you're over 95%, maybe even close to 98% with a couple passes already. And the MERV 13 filter, there's a perception that maybe it costs you a lot more energy to run, but as you can look at this ASHRAE journal article, this is in, I think, last year, August, the static pressure differences between a MERV 5 filter and a MERV 13 filter is really not that significant. Now, if you move on to HEPA filter, then of course there's a significant energy cost difference. But keeping MERV 13 filter, it may not have a significant impact to your energy consumption because the filter pressure loss is not that significant. So it's really a good place to be, to start with basic co-required ventilation. Don't have to go to 100% outside air, and then use MERV 13 filter. It's a good place to start. So you wonder, well, who are the people doing that? This is the latest P100 document from GSA. I think this just came out maybe last week or this week, even in the last couple of weeks. You see in the GSA later P100 document, it requires MERV 13 filter in 100% recirculation air terminal unit, fan coil units, fan power boxes, and the air handling unit, not to mention the provision of that in places where there are wildfire. So you go back to the first chart that we look at. What is in the air, right? That holistic element, and how MERV 13 filter can help to mitigate many of those. Now, but there's an important point to note here. The co-minimum ventilation and MERV 13 filter may not be adequate to provide the risk mitigation. Now, there may be additional measure will be required. So some of this additional measure could be standalone filters or other cleaners like UV light, for example, that can reduce that exposure and reduce the risk. Let's go through a few examples, since we know there's a bunch of audience in there that come from a bit different background. So let's first look at residential. What else you want to do besides a MERV 13 filter in your home? Well, let's look at one thing we learned from the pandemic this time is many of the outbreaks actually happen in the home. Moving forward into the future, you probably know that you and I may be experiencing that too. Yes, the new normal is you might be of some sort of hybrid. You will be able to work more from home. Our company, for example, allow us to work 2 days from home. So with that in mind, so there will be more time you may stay at home. So you want to make your home safe. Potentially, if you're going to do that, maybe you have a portable air cleaner in your working room or something like that. Or if your home has vulnerable people, provide a portable cleaner in the room for them. What about in an office? Well, portable cleaner for the entire floor plate of an office is going to be very expensive compared to MERV-13 filter or even UV light. It may be the most expensive option. So one of the things we can do is, if you reduce the density of an office, in this case, the orange is no mass, the blue is with mass. Either way is a linear relationship. So if reduce the office density, the amount of people by 50%, you roughly reduce the risk of 50%. How about in an industrial area where you don't have the MERV-13 filter and it's just a ventilation unit? So one of the things potentially you can do is provide upper level UV light and run the fan in reverse, so it draw the air up and go through the UV light to clean up the air. And how about that elevator? Well, oftentimes we get scared walking into the elevator during COVID. Yeah, because somebody sneezed in there, then you are trapped inside that confined space. But if everybody wear masks and is everything the same as all the other spaces, the elevator actually could be a safe place to be. Why is that? Because a typical elevator, if you turn on the exhaust fan, it has 72 air changes in an hour. So compared to 5 to 6 in an office building, elevator actually has much higher air changes. So the risk potentially is much lower. We calculate with that sort of air movement, it's roughly about 0.005% of risk using the Wells-Riley. So there are different things you can do in different environments potentially to enhance the space beyond the minimum outside air and the MERV-13 filter. Now, beyond those stuff that we talk about, they are also from this pandemic. We learned they're just about this whole spectrum of these other devices, what we call the emerging technology. Those technology, you gotta look at it with a more careful eye because they oftentimes need a lot more science to prove it. So, so you just have to be really careful in evaluating the manufacturer's claim and data. The air distribution is important. So if there's no need to have some direction airflow in this COVID situation, the air is preferred to be mixed and avoid this extremely high velocity of air going from one place to the other, like the Korean restaurants example you saw, or on the upper right corner, the air actually infected a person that is over 6 meters away because this high velocity of air forming a movement. We start looking at the future office and look at the differences, furniture layout. Now what you're seeing on the left is typical row, on the middle is actually cubicles, and on the right is actually quite interesting. We turn all the people 45 degrees to the airflow. The airflow is from the bottom of the picture to the top of the picture. What did we find out? We find out cubicle actually form this kind of trapping area and trap some of the air from moving. So the mixing is not as well. And out of all these three, the one that has the best movement of air and a little bit better mixing is actually the one on the right. By turning the people 45 degrees to the airflow, the air flow through the people just that much better. So airflow does matter on top of MERV-13 filter and minimum outside air. So the way the airflow does matter depending on how the furniture react with the airflow. Finally, well, not finally, but in the earlier discussion of the epidemic task force, We look at relative humidity and thought we want to keep our building 40 to 60%. Later on, we find out that relative humidity compared to the other measures for pandemic in COVID-19 is actually not as effective. So we relax that requirement and change to maintain temperature and humidity design set points rather than try to maintain a relative humidity really high. And I live in Chicago. I can tell you that 40% relative humidity in Chicago, you're going to have some issue on condensation. And I suspect you all know that, those from the northern climate. So the other piece to think about is whenever there are people in the office, we got to maintain the required supply air and the MERV 13 filter. Now, oftentimes we think, oh, you know, occupied hours and unoccupied hours. Well, unoccupied hours, that will be still cleaning crews in there. Sometimes construction people work in the off hours. So make sure when there are people in there, the equipment are on to protect them. And remember, oftentimes those people tend to be stay longer time indoor. So to create a more equitable environment, we should really protect them. When necessary, we will flush the space, right? So there was a time when we think about flushing the space with 3 air change to eliminate 95% of the contaminant is outside air. But we move forward into this equivalent outdoor air calculation. It's a simple calculation. You can go to this Excel spreadsheet on the ASHRAE website. And what it does for you is it can look at your strategies. In this case, you have 1.56 outdoor air change, and then you have a MERV 7 filter and a UVC light, 85% efficiency. So what this Excel spreadsheet allows you to do is collapse all those three strategies together and add them together. So you see the red, blue, and yellow. That means the red is 1.56, same outside air, but the MERV 7 filter gives you 2.08 air change per hour, and the UV light gives you 3.2 air change per hour. So totally, this add up together 6.84 of equivalent outdoor air. So if you want to flush through this space, 3 air changes, you don't need outside, you don't need 100% outside air. You can use these 3 strategies, and in 26 minutes, then you can flush this space with 3 air changes. So this is a simple calculation. You can download the Excel spreadsheet and it will do a lot of the work for you. And we gotta avoid some of this re-entry of the element from our heat recovery devices. You do not, now on the top right corner, it shows you, you do not have to turn your heat recovery devices off, depending on the arrangement you have. Certain arrangement is more concerning, you want to turn it off, but others you don't. The other thing to think about is, no matter it's the first SARS or the second SARS-CoV-2, we saw there are multiple high rises that through the water system or the air system, the contaminants, the material was spread to different floors. So think about trapping your plumbing system. Make sure there's water to trap the plumbing trap. And if you have common exhaust riser, make sure you have motorized damper or backdraft damper or some other device to isolate the flow when the unit is not on, to avoid this air movement from one apartment to the others, both from the air side and the water side. And other things to think about is some of this could be just maintenance issue. For example, in this case, the filter is not mounted correctly. And if you do that, 1 cfm of crack in the filter rack, it will change your MERV 13 to MERV 8. Other maintenance issue, including this one, which is a paper done by Mr. Fisk from Lawrence Berkeley Lab. And what it indicates is there are many schools actually have very high carbon dioxide level in the space. So if they have issue in the normal times, then probably they will have issue or more issue in the pandemic time. So make sure the maintenance is good so that you don't see this extra high level of CO2 in our schools. Finally, one of the things we want to look at is control and monitoring. During pandemic mode, we suggest use the BAS system to create that pandemic mode. Oftentimes we have fire mode and occupy mode in our BAS system. Why not have a pandemic mode? Push off a stroke from the operator, we'll set up the building to be ready for pandemic mode. Let's do that for the next pandemic so that we don't have to go through that whole BAS control sequence again. Or the measure space. Now there are a lot more devices come out. In the past, we used CO2 as a proxy of human being, but there are now devices that can actually measure how many people you have in the room. And also, exactly, from the toilet to the conference room to your office, at any time, how many people are there. There are counters like that, and there are devices to check the temperature. How do we think about this holistic measured space that's going to inform us in the future? What about our normal times and our emergency times? Part of that could be this virus monitoring. Now, this is not a real time, though there are some devices approaching real time, but this is actually a device you have put a cartridge in there, and it will monitor the virus in the air. Some suggest up to 1,000 different viruses they can measure, and they can give you the result the day after, like a really short time. So it can start inform you both during flu season, are your space trending up in virus build up? Or during pandemic time, are there actually virus inside the air handling unit? Now you have to send the cartridge to the manufacturer for them to do it for you. And also, some of these devices has the ability now to put in tracer gas, so you can actually measure how the airflow in your building, like what you see on the right. So again, think about how this device can help you now or in the future to prepare for better, healthier indoor. Finally, I want to touch on beyond the indoor air quality. Indoor air quality is the dark cloud of the day, but hopefully we'll go past that. Think about the humanity in the future as we all grow longer and maybe above 60 years old, maybe closer to 1/3 of the population in US is approaching that 60 years old. So how do we make them healthy? It's going to be beyond just indoor air. It's going to be about the holistic indoor environment, so we can create the best and the optimal environment for human beings to live there, to minimize the energy consumption, to take care of their health and create a better world. This will be things like all the stuff you saw just now, from thermal, acoustic, to air quality, to many, many other considerations, because it's only that we can minimize our energy and our health and create a low carbon future, so that we don't spend a lot of energy and money to take care of our older folks, which I'm quickly approaching towards that direction. With that, thank you.
Wonderful. Thank you so much, Luke. Now we're going to be moving over to the Q&A portion of this presentation. Wonderful. Our first question is, does it matter if MERV 13 filters are on supply versus return? And how about increasing outside air percentage? I think you spoke to that, but if you want to give a brief summary of your main points.
Yeah, obviously, if the air, I think the second part is easier. Obviously, if the outside air is 100% clean, bring in 100% outside air is slightly better. But as we went through the example earlier, the first pass is 89% given COVID profile. The second pass is already at 98%. So you can quickly see that the recirculation through a MERV 13 filter will quickly approach the outside air. So in terms of supply air and return air, it's probably more helpful to put it on the return air, because the return air is the one that carry all those good stuff, or not so good stuff, I should say, back from the space into the air handling unit. Now, there's also a lot of discussion putting MER13 filter on the outside air, right? I mean, think about it. If the static pressure loss is not significant, putting it on outside air also can potentially prevent the wildfire, the PM 2.5, all that bad stuff that from coming in. So there's that benefit too. Put it on the supply side, the benefit will be smaller than compared to the return side.
Wonderful. Thanks, Luke. And then before I continue with all of these questions, I have a quick question of my own. You mentioned a lot of different ways that we can improve our indoor air environments. But for some folks on this webinar that might not have the capital resources to invest in all of those technologies, can you let us know what are the most cost-effective ways to achieve a healthy indoor air environment?
Yeah, so we actually look at that from ASHRAE standpoint. You can first cost-wise, right? Or actually look at maybe life cycle cost-wise. There are a few things you can do. 1, improve outside air. 2, MER13 filter. 3, UV light. 4, portable air cleaners. On a first cost basis, probably the cheapest is potentially either change the filter. We look at that is roughly about $0.05 per either CFM or actually it's $0.05 per CFM. It's really, really inexpensive. You know, increase the outside air can be inexpensive because you just adjust the damper location, but it's going to cost you a lot to run. So on the first cost and operating cost basis, MER13 is probably the cheapest, the first thing you got to do. Now, if the next thing is potentially first cost is still not too expensive, and also energy-wise maybe not too bad, is probably some sort of UV light. Usually the cost is slightly lower than putting in portable air cleaners every, you know, like all over the place. Let's say if you have an office floor, right? Because the CADR, the clean air delivery rate is only certain amount. So the portable air cleaner, you're gonna need quite a bit of those to kind of clean the floor. So the cheapest first cost and lowest operating cost is probably your MER13 filter. That's how you want to start.
Great. And then beyond the pandemic and beyond building systems, what other things can we do to improve and achieve a healthier human environment?
Wow, this is no doubt a loaded question. There are many things you can do. So ASHRAE is focused on that in the strategic plan. Happy to work with you more on those. But your thermal comfort, right? Your acoustic, and then your indoor air quality. And there are also microbial. There's a lot of discussion about microbial, and you know it's still in process. But there's another dimension of microbial, electromagnetic wave, which is inside SIPSI as one of the elements they look at. Just a very holistic set of things. I don't know whether I can dive into all those topics in this short duration, but this is a great question, and we should try to, happy to try to work with you together on that on a separate email, or come join ASHRAE and let's explore that together, because I think that humanity in the future, health is the next carbon, maybe even more significant than the next carbon.
Wonderful. Yeah, we'll have to bring you on to a follow-up webinar to discuss health in detail. But let's go to this next question, which has 5 upvotes. So this question is about occupant density. So if only custodians are in a building after hours, there is no population density and a minimal risk of transmission. Shouldn't one of them be able to reduce ventilation based on occupant density?
Yeah, this is not an easy question to answer, because there's two things about it. On one side is if you can know how many people in there and provide the co-required ventilation, there's certainly one way to do that. But oftentimes it's not that easy to find out how many people in there. If you know that, great. But if you don't know that, that become a little bit of that discussion. But at the end of the day, it's really the risk level you want to accomplish and the measures to get there. But if you know the exact occupants and can provide the co-required ventilation, then obviously that's a way to save energy.
Wonderful. So next question, which has 3 upvotes. Does adding a MERV 13 filter cause a higher pressure drop? If changing to a MERV 13 filter, would a fan still work? In other words, does an AHU fan need to be replaced to a higher pressure fan when adding a MERV filter to an AHU system?
Yeah, for the most part, I think what you find is you may not need to do that. The filter can be completely transparent to the fan. The fan doesn't have to do anything. Now you want to make sure the MERV 13 filter pressure loss is very similar to what you have right now. And oftentimes it will be if you just seek out the filter that can do that. As we saw in the presentation, the study from the ASHRAE journal suggests that there are definitely filters out there, MERV 13, the performance very similar to MERV 5 to MERV 8. So you can actually don't do anything to the fan and the filter can be transparent to what the fan is doing.
Got it. The next question is ASHRAE working on a pandemic mode guidance and testing protocol?
So this is a bigger question. Maybe Bill can have a much better insight than I do. So in the commercial guide, we just mentioned that prepare pandemic mode. The pandemic mode will be like what you're doing in your building right now, but build it into a BAS sequence so that just like an occupy mode, when you hit it, it will engage that sequence. Similar thing here. So that will be difference in different building types. So, and also different, even in the same building type, you might have different sequence. For example, commercial office buildings, some they have to warm up an hour before it occupies, some might be 2 hours for whatever reasons. So those will be changing. Those will be different too. But like what you want to do is build all those sequence of how you control the building during pandemic mode into a one stroke by the operator, you will be there.
Wonderful. And then the next question is, are there industry practices for risk measurements?
If you look for actual measurement, I'm not aware how you're going to do that. Maybe some people do. The risk we are talking about here is really the industry as a whole right now. A lot of us is just using the Wells-Riley equation to calculate the risk level that you experience in the building. I mean, there's tons of assumption behind it, but that's one of the tools we are using. I'm not aware anything you can do on the measurement size, but then again, that may be, there are many people much smarter than me. They may be able to answer that better.
Got it. And then for those of you in the chat that are asking where you can submit additional questions, please go to slido.com and use the hashtag DOE, and then you'll be able to land on this page and include your questions. So moving on to the next question, for a building using 100% outside air ERVs plus fan coils for temperature control, which cannot handle a MERV 13 filter, do you recommend installing other technologies in the space, say in an assisted living facility?
Oh, wow, this is a lot of material in there. Now, fan coil, depending on what type of fan coil you have, For example, you saw in P100 document, GSA actually is suggesting using MER13 filter on the back of a fan coil. So there are fan coils that can handle that sort of pressure drop. You have to look at the configuration. I mean, you saw just now the pressure drop is about 0.1 something in a MER13 filter. I think it's like anywhere from 0.15 plus or minus, north or south of that. So if you have a typical fan coil of 0.3 external static pressure, potentially you can take that if your ductwork is not too much. So you need to look at that carefully, whether your fan coil can take a MER13 filter. But if your fan coil cannot take a MER13 filter, I don't know whether you want to quickly go to 100% outside air. I think if you have a MER13 filter, if you cannot handle a MER13 filter in the fan coil, then okay, increase the outside air, or UV light or portable air cleaner will be the next strategies to look at. But I don't know how efficient is your ERV. So you need to kind of do that comparison between UV light, your 100% outside air or increased outside air, or portable air cleaner, to look at those three options to see which one is maybe better, or a combination of those. Yeah, that will involve an exercise. That may be something you may want to go to a local engineer or some engineer you trust to have them do some quick study for you to see what's the best way to use those different strategies, either independently or together, to create the risk level reduction you want.
Yeah, there's a lot of different things to balance and to consider. And I want the audience to know that for those more complicated questions, we'll be sharing Luke's contact information one more time later when we're wrapping up. So you can feel free to reach out to him and ask him any questions that were left unanswered here today. But with that, I think we're going to wrap up. And thank you all so much for all of your incredible questions.
I do want to let you know that there's a ASHRAE website has a question button or question location, so they are free, and that will be a good place to go to if you have any question.
That's great. I actually didn't know that they had some form of question or chat function. That's really great. Thanks for letting us know, Luke.
Yeah, go for it.
Wonderful. So if we want to go to the next slide and wrap up Slido. Great. So this webinar is part of the 2021-2022 Better Buildings webinar series. And as you can see, we have a great lineup of presentations through April. So please feel free to visit the Better Buildings Solutions Center to learn more and register for all of those great sessions. Next slide. Great. And we hope that you will join us on November 9th for our next webinar, which is titled Reimagining Carbon Costs, Finance Your Way to a Low Carbon Future. Join this webinar to hear from experts about how they increase the use of financing mechanisms to achieve their carbon reduction plans. This webinar is going to explore how 3 leading organizations are using finance to address their carbon profile. Next slide. And if you're interested in learning more about the topics discussed today, I know we had a lot of questions in the chat about all of the resources that Luke shared. I really encourage you to download the additional resources handout from the Zoom chat box. The handout contains links to resources from Better Buildings and our speakers. So please take advantage of that. In addition, like I mentioned before, the recording of this session and Luke's slides will also be made available once this webinar is finalized. Great. And with that, I'd like to thank Luke and Marcus very much for taking the time to be with us today. Like I mentioned, please feel free to contact our presenters directly with additional questions, or if we couldn't get to your question during the Q&A period. And for all of those Better Buildings partners on the line, please remember that Marcus Bianchi and his team, the Space Conditioning Tech team, are available to provide guidance on any challenges that you might be facing in your organizations with your buildings at this time. I also encourage you to follow the Better Buildings Initiative on LinkedIn and Twitter for all of the latest news. And you can find our handles by their respective icons on the left of this slide. And like I mentioned, you will receive this slide and the recordings, everyone's emails, and the handout with resources later. Thank you all so much for joining. Thank you, Luke. I really appreciate your time and expertise. This was an incredible, incredible session, and I really appreciated your emphasis on equity and the inequalities that have been highlighted through this pandemic.
Thank you.
All right. Thank you all.